Dear ladies and gentlemen, I warmly welcome you to our first Masterclass Monday, hosted proudly by Embedded Wizard by Terra Systems. We want to show you the fundamentals of the Embedded Wizard framework today. That meaning Terra System, offers a GUI solution for the whole development process named Embedded Wizard. We at Terra are working on UIs since many years, so we offer a professional solution that simplifies your GUI development from the beginning until the final product. So this technology enables you to create platform-independent and high-performance graphical user interfaces for both MCUs and MPUs. My name is Kristen. I'm responsible for marketing and communications here at Terra Systems, and our other host is our product manager, Manuel Milic, who will give you a deep dive into the Embedded Wizard framework and showing you around what you need in order to create your own GUI with Embedded Wizard. So Manuel, the stage is all yours.
Yeah, thank you very much, Christine, for your pleasant introduction. Good morning, good afternoon, good evening to all of our attendees worldwide. It's really a pleasure to have you here and to get this very first webinar started. The main focus of the whole series is really to give you a proper understanding and to deep dive into our technology. That means the first webinar series and the first episodes will cover more or less the basics, the fundamentals, and hence also this very first one where we just cover the basic building blocks and then deep dive into further aspects with every next episode. For today, we have planned some overview, or to give you a proper overview of different aspects. First of all, I want to present you the entire architecture, how Embedded Wizard, how our framework is set up. Then I'll cover the Embedded Wizard Studio. That's our IDE, the integrated developer environment, which enables you to create the user interface on your PC. Inside the studio, we have a dedicated own programming language, which is the so-called Chora programming language. I will also give you a brief overview on that. Then we have the so-called Mosaic Framework, which is the base of every UI project, which covers things like drawing rectangles, etc. Then another very important part is the so-called platform package. This one is the abstraction layer to the underlying system, which uses some graphic acceleration if it's available or not, or goes to software rendering, but also takes care about the code generation and the resource conversion. And finally, we have the so-called build environments. That's the SDK that you probably already know, where you can go ahead and get started very easily. So let's get started. And what I do not want to do is to give you only a slide web presentation. So I really want to show you things live and where you also find further information later on in the internet. So that means I'm just now closing that window here and simply open as a very first stuff the so-called Embedded Wizard knowledge base, which is the base for all different kind of technical documentation and information. And as a very first step, I go ahead for a very short overview. So inside the overview, you see more or less the whole architecture, how Embedded Wizard is structured. First of all, inside your GUI project, you have, of course, dedicated resources. So that means bitmap files that can be PNGs, that can be GIF, that can be JPEGs, etc. And next to that, the other thing is that you also have some kind of TrueType fonts. These are the represented here by the TTF file. That means those TrueType files and fonts are used in order to display your strings and text views accordingly. Next to those primary resources, so bitmaps and fonts, you of course also have your own project. With Embedded Wizard, you probably already know that we follow a source code generation model. That means you program your GUI project inside the so-called Embedded Wizard Studio, which is represented with a screenshot here. And finally, you will then generate out of that project C code for the underlying system. Inside the studio, you also have of course, the possibility to prototype the UI application instantly inside the Embedded Wizard Studio. And that brings the big benefit that you do not need to go to the target, that you do not need to invoke the compiler, the linker, flash the debugger, etc., in order to see your currently developed UI instantly. So we say our approach is to stay as best as possible inside the Windows world, inside your PC environment, to have a very high pace at the end when it comes to development, in order to implement new features, in order to debug your stuff, also for maintenance mode, etc. And then when you have got the proper environment up and running, then you will then generate the sources according to your project. And this one here represented by the so-called resource converters and the code generator. And these one already belongs to the so-called platform package. The platform package, as you see, is then running on two levels, or on two levels. The first level is here inside the studio, which is then used inside the studio in order to convert the resources. So that means the PNG files and root files, for instance, or your own software. Means that the software that you have developed inside the studio is then taken into account and generated to proper target source code. Usually when it comes to the embedded system, it is generated in ANSI code, and so that means in C files and H files. The platform package, as already said, is used here in this higher level inside the studio, and of course also used when the prototyper is started. So that means when you simulate the UI project inside the studio, the prototyper gets started, and when showing the resulting GUI, already the known information from the platform package are taken into account. So that means if you have, for example, an RGB 8888 color format used, then this is already represented inside the prototyper. For instance, when you have another color format like a grayscale color format, Luma 44, for example, then the GUI is already then rendered in the same color format as it would then would be rendered on the target system. So that means the platform package is used for two kind of things. First, for the converters and generators, and the second one to show the GUI during development time in a proper way inside the studio. The platform package, the second part and the second layer, is then on the embedded system, on the target hardware. So that means it comes with a dedicated graphics engine, which takes care about all the rendering processes, so how to draw a rectangle, how to render the bitmap, how to draw the text view, for example. And this is taken care in the so-called graphics engine. The runtime environment is more or less the abstraction layer to an operating system, to the, or if any, or to the proper C standard library. And depending on the edition that someone has purchased or licensed, it's either available in full source code, so that means you have the full control without any further dependencies, or as a library, but this depends on your licensing environment. So with the generated C and H files plus the dedicated graphics engine and runtime environment for the platform package, this one builds then more or less the entire GUI application. However, from the overall architecture, this one is just one part. So we see ourselves as not the dominating one inside the whole firmware, inside the whole application. It's just taking care about the GUI aspects. So that means when you create your own user interface, you will then use the generated C code plus graphics engine plus, which is unfortunately not shown in this figure here, some glue level for initialization and how to feed data from the touch driver, for example, to the graphics engine, to the platform package. This is then used and integrated into your application. So this is just a very rough overview how this studio, the platform package, etc., comes into place. In order to get started instantly for a dedicated development board, maybe for ST microelectronics, from Microchip, for NXP, etc., we have set up dedicated SDKs. We call them build environments, and those build environments are then used as a starting base for dedicated evaluation boards or for Android, for example, etc. With those, you get dedicated examples, you get the just mentioned glue code, so initialization routines, you get project files, you get also the platform package is already integrated into that build environment. And so you can really use that as a starting base, as a template for your GUI project. Okay, so this is just a very rough overview about the overall system, about the overall architecture. Now I want to deep dive into the other aspects. For that, I'm just go ahead and start the Embedded Wizard Studio. What I'm doing here is the Embedded Wizard Studio Free Edition. This version can be used instantly after you have registered and downloaded and installed it from our website. And what I'm now doing is just create a new project. Creating a new project, now I'm just doing an empty project without any dependency to any embedded system, to any embedded target. I'm just say, okay, this is my master class episode 1. And create a new project. The default folder where this overall UI project is stored is inside the documents folder, and there, so of your user profile within Windows, and there inside the projects folder, but you can of course change that, so it's just the default one. So what do you see here now? Inside the studio, you see the overall IDE. So what is this all about? First of all, on the very top view, you have the so-called menu bar. You have a toolbar. With that, you can, for example, just start the prototyper instantly. As of now, I've just a very empty project, hence you see just nothing. But you can start the prototyper right now. You can also zoom in and zoom out, for example, according to your needs. You can do a restacking, which is there. And of course, you can of course save your project or open other projects. So this is the menu bar on the very top here. Next to that, we have the so-called navigation bar. And you see here, which is this bar here. Inside this navigation bar, this is structured like the project is set up. We have the overall project, which comes with dedicated units. You see units like core, resources, graphics, etc., application, but it also comes with dedicated profile or the default language. Those elements that you see here are the so-called bricks. A brick is the visual representative of a logical element, of a member of the project. By double-clicking into a dedicated brick, it opens, and that you see also here the navigation bar is also indicating that this application is opened. And you can double-click now into another brick like the application, and then we are in our first main window of the new application that we have set up. With Embedded Wizard, we try to make things visual as often and as best as possible. That means things that can be drawn inside this view, is a so-called composer, are drawn instantly. So like the entire screen is represented by this pattern here, whereas other things that also come into place when a GUI project is developed are then and cannot be drawn, like methods, like classes, like enumerations, etc. These are represented by these bricks. And as you see here, by using this navigation bar, we can also go to other views back and forth, like the unit, which is the container or a group of dedicated classes, for example, in that application unit here. This one cannot be drawn, of course not, but it's represented as this kind of brick here. So we have the composer. By selecting a dedicated element like this property bounds here, then it opens inside the so-called inspector on the right side, or it selects then inside the inspector a dedicated view, like for example here the bounds. By selecting the bounds, you can also then see inside inspector, okay, what is the current setting? And as of now, the default setup for the bounds of a new project is set for the bounds for 640 by 480 pixels. Of course, you can change that. So let's, for example, say 800 by 480. Hitting here the reload button, and then takes into account of this setting here, and then you see that this one changes immediately. Or for example, going to other 480 by 272, hitting OK, reload, and then it shrinks. Of course, you can also interact directly inside the composer. So you can use the mouse, for example, to change the bounds here, for example, and change that according to your needs. So this is of course also possible, but if you need to be pixel precise, then sometimes it's a little bit better to select the property bounds, for example, inside the inspector here, and hit the dedicated or change the dedicated value. Of course, you can also search for a dedicated member of this currently opened view for the bounds and change that as well. So this is of course also possible. So this is, as said, the menu bar, the composer, we have the inspector. On the left side, we have the so-called gallery. The gallery is used for to drag and drop elements from the templates or from your own implemented classes into the project. So for example, going to the project and drag and drop a dedicated unit into this project view here just adds a new unit to your project. Just removing that, not needed. Or going back to the application, you can then add, for example, new elements there, like a new, let's see, where is it? A new text element there, and can you position that? And as already mentioned, you can change the bounds instantly inside the view. So this is the gallery. Of course, when implementing own classes, let's say I'm here in my unit application and I'm adding a new component there, which says, okay, this is my screen, then you can also go ahead and change the view inside the gallery here to the browser mode, and for example, search all of your own implemented classes. And as you see here, there's now the application screen unit appearing, or the class, not unit, sorry, the class appears, which can also then be used, for example, into the application and be dragged and dropped instantly into the view. However, as of now, it's not showing any content because it's just empty, but by double-clicking into an element, then the implementation of the class is then opened. And as you see, it's just a very empty one with dedicated instructions here. And for example, we can add a new rectangle there, just a simple one. Of course, selecting that inside the composer, changing that into the selecting that and changing then some values inside the inspector is of course also possible. So let's take this color here, and now going back to my application where I've just previously added this new class here, so making an instance of it, so making an object of my new element, the screen element just opens or represents the currently changed view. And with that, you can really focus on dedicated implementations of different objects of different classes at the end. Embedded Wizard itself follows a very strict object-oriented approach. So hence the meaning of classes and objects. Of course, you can derive what you see by changing different view. So like my new screen class that I have added is derived from core group, is derived from core rect view, core view, etc. And this is just you see the inheritance of the new implemented class application screen. So menu bar, navigation bar, template view or the gallery with the templates and the browsers, which can be switched, the inspector. Then we have three different aspects. For example, when I'm hitting here the mouse, then you see on the bottom line that this is the so-called status bar. You see, for example, with the mouse position, or when I've selected the element, what size does this have, etc., and gives you just some brief information about the current stuff. So this is the status bar there. Next to that, there are two windows missing. The first is the so-called log view, which gives you dedicated information about what's happening in the overall system. It also produces further information when you generate the sources, when you start the prototyper, then you see that it's prototyped, or gives you also warnings or error messages when you have programmed something which is not happening as expected. The final window that we have is the so-called editor. And before showing how the editor works, I just would like to add also a new image to my project, and therefore I've just added a new prepared a dedicated bitmap resource for that project, and for that I'm just simply drag and dropping this element into my unit. However, this bitmap is now not used entirely into inside the project. It's just added as a so-called resource. That means it's just a reference to the proper image in that case, which is stored in my dedicated user folder here, C users, Melich desktop masterclasses PNG, and you can add different other aspects for this bitmap view, but this one we will cover later on. So for example, I have now this view and how to use, I have this image and how to use this as an image view. So going back to my application, for example, adding and drag and dropping an image view, and now changing the reference from the default bitmap image to my new masterclasses image. Of course, this image is a little bit bigger, so I need to change the sizes there. So you see it's getting bigger and bigger. However, it's just too big in order to be covered on the entire screen. And of course, you can change, of course, the behavior. So that means for the layouting, it can also be set to resize in a horizontal or vertical way. And finally, you can also tell for the alignment that it should be scaled to fit or scale to fill. And let's say for vertical, that's fine. And now you see it's it's getting scaled according to the proper environments there. This is how to add bitmap resources, for example. So another element that we have here inside this gallery is, for example, a so-called touch handler. So adding the touch handler here is something where I just want to say, okay, when I have this screen, or if I have now this image here as an area which should be covered by touch interfaces, then I'm just adding this simple touch handler on top of that. And now with every click or every touch input and pressed event, I'd like to get informed when this image is hidden. Of course, this simple touch handler, for example, is not bound to a proper rectangular area. It is can be a polygon shape as well, as you see here. So how to connect now events on that? So we have now added this very simple touch handler there, and next to that I need to add a dedicated slot method. A slot method is something similar like a method, hence the name slot method, but it's more used to decouple the proper way from the someone who's calling the method and make this prepared to work in a more asynchronous mode. So you usually have a sender which sends a signal event to this slot method, and this gets then invoked. So it's usually used in GUI development. Probably you already know what to do with that, but for that, it's usually heavily used in UI development. So nevertheless, what's the difference compared to a general method? It does not come with any parameters given. So it's just a method that is invoked by receiving a proper signal. So by double clicking now this slot method, the last window that I'd like to mention is opened, which is a so-called editor. And now you see how the editor looks like, and in every or nearly every programming language, you can also type something like a printf, and this is also, of course, working inside Embedded Wizard. However, it's not printf. In our case, it is the so-called trace command. And then I say, okay, hello world, for example, world, and that's it. What you now see inside the editor is our own programming language, which is the so-called Chora. So what's happening now when I also select now this touch handler and would like to send a signal in case I'm touching that. So for example, on press, or when the user presses on that event, just say, okay, let's emit a signal to the dedicated slot method named slot. Of course, I can also say on press, just renaming that, and then this on press slot method is invoked. So pressing now the play button and hitting just says, okay, I've got an error. What is it? I missed this one. So you see, therefore, also the log window is also used in order to show my bugs that I'm doing during live coding. And now it indicates, there's a new pop-up coming up into my debug window. So changing the view to debug says, okay, trace hello world. And with that, you can easily add your dedicated printfs and traces and see what's happening. So this one is here the so-called code editor. So what other windows do we have? For example, when I'm hitting here the prototyper and hitting several times on my simple touch handler and receiving the trace messages, we can also do something like debugging. Therefore, pressing now F9 on my keyboard just hits or opens a dedicated breakpoint. That breakpoint shows that when I'm hitting a breakpoint during development, that the overall execution is then stopped, and I can further then go ahead and do a single step debugging. So therefore, I'm just opening further windows. For example, I have here the variables. Let's show also the call stack, for example. Where am I into my own application? I can also give more information about the overall RAM usage, and of course process that in a single step modus. So debugging that and do further analyzing of different aspects, etc. So this is something which is also possible when doing the prototyper. So next to that, inside the studio, we as you see here inside this on-press, I'm using here the Chora language. And this is now the second element of our today's agenda, to give you more information about Chora itself. So why did we implement an own programming language? Why is there Chora used? Just a side note, Chora is not a domain-specific language, so it's a pure programming language, so you can do anything. so the question would be, why do you not use C or C++ or JavaScript or other scripting languages? Why have you programmed your own programming language, Chora? First of all, there is no general purpose programming language available which is dedicated to GUI development. For example, if you want to deal inside Chora with rectangles, with colors, with elements that belong to GUI development, then this would be something that you will not find in a general purpose programming language. So we added that functionality. So for example, we have the bounds that I just mentioned before, and I can then say, okay, let's take there into account a new bounds for 200 by, I don't know, 500, 0, 0, something like that, which is the representative or dedicated rectangle, for example. Or if I would just add a new rectangle there and say, okay, this rectangle dot color goes to red, green, blue, alpha, something like that, and hitting again now the prototyper. Oh, there was a breakpoint, just removing that. I would just now shrink the bounds, etc., but would also, for example, change this color here to red, for example. And this is just by invoking the proper call inside the statement here. So we have built-in data types to deal easily with rectangles, with lines, with points, colors, languages inside that language. For example, to change from German to English to French to Chinese, etc. So this is all built inside this programming language. Furthermore, also, well-known software design patterns that come into place when dealing with GUI development, so like model view controller, model view presenter, model view view model. All of those are supported instantly inside this programming language, and this, for example, is done by the observer pattern. Every UI pattern have in common, so the previously mentioned one, have in common that they rely on a typical observer pattern. So we have an observer and observable, and you say, okay, if there's something changed, then just emit a signal. In our case, we would send a signal to a slot method, which then invokes a notification that different things have happened inside the system. So for example, calls to that would say attach observer, sorry for that, etc., etc. However, something which is also very important to know if you're not familiar with the API, how does now attach observer work? We have also built inside the application a so-called or our instant and context sensitive help. So I have now hit the cursor onto the attach observer statement, and by pressing now the help button, opens the embedded wizard knowledge base, and you can now see where do I now have my attach observer. It's there, and it says to me how to use this method. So attach observer, slot expression, object expression, etc. And this can then be used in order to see how something is working inside embedded wizard. So everywhere where you are, for example, I'm now here on this rectangle, pressing now F1 key or this button there opens the knowledge base and shows how to use dedicated elements and how to use it. So it's also very, very neat function inside embedded wizard, just to mention that. So back to Chora, what is there? We have the support for UI specific topics. We have the support for UI patterns inside the language. It's fully object oriented that you already see. I have here this rectangle color, which is the objects that I'm using inside the view. Or for example, I have also my screen, which is the object that I added before below this fuse here, so which was that one. This is there and can also then be used for further stuff. So it's fully object-oriented support inside the UI stuff. And another very important benefit of having this own programming language is that we really took care to create a very safe and a very strict programming language. So you cannot deal with pointers, for example. You do not have any initialized data. You cannot access already freed objects, for example. So it's a very safe and a very strict language. However, as you see there, it is very inspired by modern programming language. So if you're familiar with C, C++, Java, JavaScript, C#, then it's very easy to learn Chora. I would say if you're used to do software development, then it's a couple of minutes and then you're familiar with that. Of course, you need to know how this additional features like what I mentioned before, observer pattern, how this is used, but this is well documented with proper examples. This takes a little bit more time, but if you're used, if you know how to use it, then it's very, very easy. For example, of course, you have if statements, you have switch statements, you have for loops, etc. So the classical expressions are, of course, available. Next to that, as already said, the Chora programming language is not a domain-specific language. It is a dedicated own programming language, whereas it is Turing complete, so you can solve any problems. You can do UI development, but you can also program your dedicated own methods and routines and algorithms with Chora, so it's not limited. Also, benefit of having this own programming language available is when starting the prototyper, then the UI code that we have here is interpreted instead of compiled and executed. And this gives more flexibility inside during development time. However, when it comes to the embedded system, to the target, then it is of course not interpreted. It is before generated. So for example, closing that here, generated by hitting here this button, this icon, build this profile inside the menu bar. Then it's going to be generated. So then the C code is then generated out of Chora, and then this is then used with your dedicated hardware compiler, compiled, linked, etc., to the embedded system. And so we have the possibility first to run this in an interpreter during development time, and then using that for the generation process when it comes to the embedded system. The generation approach also gives much more flexibility when dedicated hardware system or the dedicated final target system is taken into account. Usually when it comes to the embedded system, we generate, as previously mentioned, ANSI C code and H files, so C files and H files, but we can also generate JavaScript and HTML5 sources. When going to the project, for example, you can define that by selecting the profile with dedicated platform package. Selecting that says, okay, now sources for Win32 are generated, or for example, when I select the Tara WebGL RGBA 888 platform package, then JavaScript and HTML5 sources are generated. And that means you have also inside the own GUI project multiple ways of selecting how to generate sources, how to convert resources to your underlying system by selecting the proper platform package. So this is all about the studio. I just spoken something about Chora. So this is the base of every UI project, this own programming language. Now I want to take care about the so-called Mosaic Framework. You already see that inside the project here. What is the Mosaic Framework? Well, it's a framework which is the base in order to be used for your dedicated UI project. When I'm here inside my application and when I have drag and drop rectangles and text views, for example, these are, as you remember, double clicking opens the implementation, are implemented with Chora and structured and grouped inside this Mosaic framework. So opening now here the project gives you all the implementation of views that are here available inside the gallery. For example, we have views where it's line and rectangles and borders, etc. And this is then used in order to create your user interface. Just remember, I said Embedded Wizard is object-oriented or follows the object-oriented approach and paradigm. That means that you could also derive from our Mosaic framework, from our GUI framework, the dedicated elements and create your own subset of a customized rectangle view. Just think about, you have this rectangle view and you do not want to, of course, please avoid to make any changes directly into the views, but for example, you can also make a proper derivement of this views rectangle, for example, or any other one. And so you can add your custom view or extend the proper element and extend it according to your needs, according to your individual requirements. So inside the Mosaic, what do we have? So for example, inside the views where you just were, it was the text view, you have wallpapers, you have the image views, you have the rectangles, you have the lines. You also have the functionality to draw vector graphics with filled path or stroke path elements. You can do something like warp images or warp groups, which is perspective transformation. So you can do some 2.5 2.5D views, like cover flows, for example. This is something that you can do with those views. So what else do we have? Of course, all the effects which are there implemented for very simple effects like integer effects or color effects, Boolean effects. You have there all the timers. When it comes to screen transitions, there are the dedicated or preset transitions available to show or go from one screen to another and vice versa. So this is something which is implemented there inside the effects as well. Next to that, we have for the graphics more a subset of that. I do not want to go too much stuff, spend too much time inside that one, which is a very basic element to do a proper drawing, for example. Dealing with the resources is also there. Of course, when what you have seen before, when adding a new image into the view, then some default resources are used, and these are just there for your instance inside this resource folder. There are default bitmaps, default fonts are there, but please keep in mind that these are not used per default also on the embedded system. If you do not use those default images, then they are not taken into account. They are not generated, of course. So very important. It's just default ones available in order to have something up and running. And finally, we have the unit core, which is also very base elements. For example, the touch handlers are implemented there. You have something like very unique one. It's task queue, so it's not something which is then used inside a multitask environment. It's something where you have a job list and jobs needs to be enqueued into a queue, which are then processed step by step, and this is something which can be used also inside your GUI project, for example. So this one, the core, as the name implies, is a very basic one. Of course, there you find also different kind of events, the predefined events, so for key events, for example, or dedicated touch events. And also very important, everything inside this Mosaic stuff, the Mosaic framework, is, as said, implemented inside Chora. That means the whole environment, so just opening, for example, this the editor for the change view state, all the elements are there implemented, are documented, and can be used. Something about wording and how this is used. Inside Embedded Wizard, of course, there are some private stuff which are only used when used inside a dedicated view. So, for example, the next in previous variables there, these are with lower cases mentioned, whereas other elements are starting with a higher higher case character, so change view state. All public members that can be used in a safe way inside your application should rely only on this one with the higher case methods and properties, etc. Whereas the lowercase or elements starting with a lowercase character should be not used directly, because these are internal members and internal structures. So this is something all about the views inside Embedded Wizard, and this is just the Mosaic framework. Please avoid and simply do not do any changes inside the framework, the Mosaic framework. If you wanted to change anything, just make a copy of it, or the better way would be to derive from one aspect or from one implementation of a dedicated class inside your GUI project as well. So this is all about the Mosaic framework. I already mentioned before the so-called platform package when I selected here the profile. So what is now this platform package? So going back to knowledge base is something which I already mentioned before. The code generator is part of the platform package, which takes care about generating the sources that you have implemented inside the Embedded Wizard Studio. It also takes care about the resource conversion. So when you are using the PNG file, what I've used here below there, these are then taken care and generated into pure C code. So how does this look like, for example? I have here the project, selecting now another platform package like Raspberry Pi, for example, and hit now the so-called build this profile button, or hitting F8 on my keyboard, and this opens now, this now generates now the sources and makes a proper conversion depending on my selected profile. And what I've now added, or what Embedded Wizard has now added, is the so-called profile brick, which produces C files and H files as mentioned before. So this is for this resource conversion, of course, used. Code generation, resource conversion. Then on the embedded system, on target, you have the so-called graphics engine. But as mentioned before, this is also used inside the prototyper when the UI is coming up, where you can also select, when licensing, different frame buffer color formats, and you see we offer quite a bunch of them. Just to give you a rough idea, RGBA 888 is the 32-bit per pixel color format, which is used when you want to display a big range of different colors on your display. Then we have RGB 888, RGBA 444, RGB 565, Luma 44. This is our answer for monochrome display, so a grayscale format. That means with 4-bit each for alpha and luminance, hence Luma 44, luminance and alpha with each 4-bit. Grayscale format. And finally, we have the so-called index 8 color format, which is a palette-based color format, whereas the palette, the so-called color lookup table, is generated according to your user interface. And with that, you have a very nice functionality to really shrink down the used memory footprint a lot, because you only then need 8 bytes per pixel, so 8-bit per pixel, 1 byte per pixel, sorry, yeah, shrinks down the memory usage a lot compared to a RGBA 888. Question is that I received from customers several times: when do I need to pick RGBA 888 or this one? So does this one, RGB 888 or RGB 565, not come with alpha blending? Because there's no RGBA 888, for example, like this one. And then I said, no worries. It's only about the frame buffer color format. It's not how internal bitmap blending, for example, is performed. The color formats which have a dedicated alpha channel, like RGBA 444, RGBA 8888, this one, or also in X8, for example, those come with a dedicated additional alpha channel, which is then used when you want to have another video layer inside, or another UI layer inside your application. So for example, a video layer. Just think about a video that is going to be displayed in a dedicated separate layer, which is from the Z ordering below the GUI layer, and then you want to do some on-screen display, some overlay with the UI on top of that video layer, or camera stream or something like that. Then you need to of course take care about the proper alpha blending inside the GUI layer as well, so that it can be put as a proper overlay on top of that video layer. And with those color formats, the RGBA 888 and the RGBA 4444, for example, or as well Luma 44 and NX8, those have this additional alpha layer inside this frame buffer color format available, which enables you to create the proper alpha channel or extra alpha channel inside the window. So this is different frame buffer color formats available for the platform package. And finally, we have the so-called runtime environment, which is the abstraction layer to the used operating system, to the used standard C library. But please keep in mind that Embedded Wizard itself has no requirements to use any operating systems. There are just 4 requirements which are essential for Embedded Wizard, which means we need a 32-bit system. We need to have access to the system ticks in order to process effects, animations, transitions, etc. We need to have access to the memory in order to allocate memory depending on the UI application stuff, for example. And finally, the 4th thing that we require is to have access to the pixels in order to transfer the pixels to the display. That's it. With those 4 elements and 4 requirements, there's no need to have an operating system, so no need for mutexes, semaphores, something like that. And that implies that you can also run an Embedded Wizard UI project on bare metal. But with other words, you can also use any operating system with Embedded Wizard. So that's not a problem. So this is all about the platform package. Where is the platform package now used? Or what do we deploy to our customers, and what is something that is used inside the overall getting started process and the bring up is the so-called build environment. The build environment, as I just mentioned in the beginning, is the SDK. It's our ready-to-use developer kit, where we want to simplify the bring up for customers. It's seen as a template and well structured. So for example, let's go ahead with the NXP environment. You select the dedicated platform that you want to go ahead with, RD1060, for example. And then it already says in this documentation here, what are the prerequisites? What do you need to have? You need, of course, the board, the cables, you need the components. And then you see that there's the Embedded Wizard Studio. You need the proper platform package to generate the sources and do the proper resource conversion. And finally, this build environment in order to get started. It comes usually in this manner. So we have the application where the generated source code is there. We have a project folder where we deploy ready-to-use projects for various IDEs, for various toolchains like IIR, like Kyle. When it comes to the semiconductor manufacturer, they often have their own environments, so like MC Expresso, like Cube IDE forever, for example, and these are also deployed inside that project there. Finally, there is some sources also available which are not generated. So all the initialization stuff, when it comes to the target or the initialization of Embedded Wizard itself, this is not generated by the studio. Only the GUI application is used when it comes to, or it's only generated. So that means all the custom settings and environments, this is just handcrafted code according to the platform and not overwritten with every generation process. So no worries on that. It's proper source code and can be used for your further development, of course. So this is the main application. Next to that, we usually deploy a couple of ready-to-use examples. Just feel inspired by them and open that, generate the sources, and then compile and link it to the and flash it to the target as explained here. Yeah, and then you see the platform package, which is then adapted and tailored and suited according to this chosen platform. In that case, the RT1060, which uses the pixel pipeline, for example. It also comes with the so-called RTE, so which is the runtime environment. And this is, I said, the abstraction layer to the standard C library, as well as the operating system, FreeRTOS in that case. Then we have also some target specific code, which are something like a board support package, which is BSP files, where drivers are used, where operating system calls are used, more specifically for the overall integration, where usually initialization is done for various peripheral elements, so for touch, for hard buttons, etc. And that's it. Finally, there's sometimes also a third-party folder, which is, as the name implies, a third-party container for third-party sources and files and scripts, etc., like GCC compiler, which we just deploy for the make system to have very out-of-the-box experience when it comes to get started the first time, or other things depending on the platform. Yeah, and this comes as a template. So it's something where also customers ask myself, do I need to build my application on top of the build environment? And I say, no, it's not necessary. It's just a starting base, a template to see how everything is structured. It shows how Embedded Wizard is initialized. It shows how the overall workflow is, how the main loop is progressing, etc. And this is something which is then ready to use and seen as a template, as a starting base inside the build environment. Of course, you can use that for your further application, or to build that on top of your application, or you can use that as a reference and then take all the initialization routines and all the things that we have set up there into account inside your own project, inside your application. So it's not necessary to use our build environment for your application. As said, it's just a template. It's just a reference at the end. So and this is now the build environment. Further on, it also explains now here in this documentation how to do the very first UI example, how to invoke the compiler, how to get started on the platform, etc., and also some outputs on the console, for example, how to use third-party stuff, etc. And this is also there. So this is for the build environment. It also says what are the essential stuff that needs to be used when it comes to your own specific hardware. So, for example, it tells you, okay, what should I take into account when using the my own hardware, if I have my own display, my own board, my own layout, my own drivers for different peripherals. It is explained what things have to be adapted if you do not want to use an evaluation board, if you have your own hardware design, and what things are essential to be configured in a proper way. So this is for the so-called built environment. And yeah, that's for now. So going back now from my demonstration purposes, now it's your turn. I've spoken a lot, and I think my colleague Christine will now give you a poll in order to let you know what topic we should discover in our next masterclass on next Monday.
Thank you, Manuel. Now, yes, we come to our poll. Here we go. So you can decide now which topic will be covered during our next masterclass Monday. I see answers are coming in. I will give you another 30 seconds so that you can think about it a bit and then give us your vote for the next masterclass. I see they're still coming in. Okay, let's close in 5, 4, 3, 2, 1. Thank you so much. Okay. What is next? Great. We want to now come to our questions and answers. Let me see what you guys handed in. Let's start with this one. Manuel, are you ready for some questions?
Yes, I am.
Great. How do I simulate only the view I'm currently working with?
Okay, so first of all, I'm just now showing my screen again. So the question was, sorry, can you just repeat?
Yep. How do I simulate only that view I am currently working with? Wants to know one attendee.
So when going back to the IDE of Embedded Wizard, as you remember, we have added 2 items, and especially 2 class as well as the screen class. When I press the started prototype with the application class, which is the same as a shortcut Control plus F5 on your keyboard, then the application class gets started, which is defined inside the profile. So there's the application class, application in that case, and everywhere where I am, so for example in the project or just in the unit, every time I press that screen, the dedicated application class, so the root entry gets started. Whereas when I'm inside a component like the screen here, you now also get the choice to start only the prototyper with this screen. So that means by pressing the play button here or pressing only only pressing F5 starts the prototype or the simulator only with the composer view that you currently have opened. Of course, you can also now go ahead and start the prototype with the application class from one specific implementation, and this gives you a very nice way of really focusing on the implementation of core classes, of core elements, and yeah, that's the usual way.
Aha, that is a very good news. Manuel, I have another question coming in from an attendee. Chora is used to generate the sources, he understood. How do I extract the documentation afterwards?
Okay, so when I'm inside the screen, sorry, inside the embedded wizard, then you also have the possibility to say under the build option, extract documentation, and then Embedded Wizard asks you what kind of units you would like to create. Usually, you do not want to get the documentation out of the Mosaic class because that's what you're using. Usually, you want to extract your own application. Hence, you just select the dedicated units that you would like to do. Set OK, the documentation folder, and finally just hit extract, and then the application gets extracted like in that way. And here you go for the CHM file, which can then be opened. Of course, now it's not very well documented, but anyway, it gives you proper information about what have you done inside your own project, where is the path of derived classes, etc. And that is a very nice way.
I see. Actually, there's more questions coming in, but I'm afraid I have to limit it to one further question, as we already are a bit over our 1 hour. So at this point, I'm very happy that you are still here. But let me post that last question. The studio is to generate source codes, one attendee stood. Can I do this automated, for example, with a batch job?
Yes, to do that, there is the so-called Chora C tool available. So when just going now back again to the knowledge base and just type Chora C, then you see that there's a so-called Chora C command line compiler. You usually find that within the program files of Embedded Wizard, and then you can simply invoke it from a batch job. So when you have some continuous integration tools up and running that can be used in order to generate the sources out of an Embedded Wizard project immediately inside your defined scripts. And however, just one note, this is not working in the free edition. It's only available in the professional edition of Embedded Wizard.
Okay, thank you so much. Before we now come to the hint for some relevant resources and links, I would appreciate if you could spare another 2 minutes to fill out a tiny questionnaire in regards to the masterclass series after we close this webinar. You will just stay in that window. It will just open up after the webinar closed. So now, Manuel, what's your final hint in our first webinar Monday?
First of all, I'd like to thank you very much for your time. I just saw that other questions coming in, whether this webinar will be made public. Yes, of course it will. So therefore we have created a dedicated website on our website, which is Embedded Wizard /Masterclass Mondays. And just scroll down a little bit, and what you see, we are now here in this first episode here. We will update that hopefully soon, and then you see also the agenda for the upcoming masterclass for next week. If you do not remember that URL, no worries, just go on the website and just go to the very first item there, which leads you back again to this entry page for the masterclass series. So this is for the masterclasses, and of course other links are there. And I said the whole episode will then be available afterwards for offline viewing if you have jumped in later on. So that's for now. Thank you very much. We are very happy that you stayed tuned for the whole more of 60 minutes right now, and we are very looking forward to welcome you again next week with a new topic, depending on your vote, of course. And thank you very much for your time. Stay healthy and goodbye.
Thank you also from my side. Bye bye.